In game engine development video number 30, follow the video as is. There's no need for us to change anything. But in video 31, making the ship respond to the arrow keys, there are several issues that we will have to resolve, and we will go into a debugging mode. From the start of video 31 towards somewhere when we start adding our Qt header file for the key press event, this is what we need to do on our part. First, we got to make sure that our Qt sandbox game is in our add-in Qt add-in project mode, which you could tell here that it is already in because the option convert project to Qt generated project is available. So that's how you know. To make sure, you could see convert project to Qt add-in project just to make sure. Okay, now after you convert to an add-in project, you click on Qt 5 and go to Qt project setting and select Qt modulus. From there, make sure the checkmark is on GUI. The reason why you want the checkmark on GUI is because the Qt add-in will automatically include all the required library and the include path to our project. Also, all of our event, the Qt event header file or the Qt key event of the Qt header file could be accessed once GUI is selected. So make sure that's checked. Okay. And there's two ways to include a header file, and I believe we touched base on this with an earlier video. You can include the class name of the Qt class itself, or you could use the .h. The only difference between using this and this is this. If you right click on the Qt style of the header file, right click on it, it is actually go to an include Qt event.h. So in other words, it's like a middleman in a sense. So you can either use this version or this version of the Qt event header file. Since I'm already using the Qt style, I will just stick with it. And let me fix this real quick. Now that we have a header file correctly added into our project, just follow the rest of the video until towards the end before Jamie compile and run the program. Now here's a heads up. Those of you out there who were able to follow the video completely and compile and run the program with no hiccup or no error at all, this video, you could stop watching this video and go to the next one. But for the rest of us, this is where our debugging process will start. Now, if I was to compile this as is, the code as is, how it is exactly like in the video. Let me compile, run it, and let's press the arrow key. And you notice our ship just disappear. Is there something wrong with our program? No, not at all. The only thing wrong about the program is it is a logical error. Now to see the reason why. Now let's start debugging. Okay, now we have to ask ourselves, okay, what's going on? The first stage or the first step to do is that we're going to add a new method into our vector class, the vector2d.h. Did I say class? My mistake. It is our vector2d struct. And the new method that we are going to add here is a toString method. And this method, all it does is that it returns back a string version, a string representation of our XY data. The required header file that we will need to put into our vector2d.h is include string, and we are going to using namespace std. Now here is the line of code. You could pause this video so you could type this out. And once you type that out, just save. And now let's go back to our mygl window.cpp. The next thing that I'm going to add to help us debug our program a little better is go to your mygl window.h, and we're going to add this method to our protected, a new protected method, which is void resize gl. And what this does is that every time you resize your window, the viewport, or our, how you call it, I'll just say our object or our ship will be scaled appropriately according to the window. Once you type that in, let's go back to our CPP and I'll show you the code for that. Okay, right here. So resize, let me enlarge this. And let me highlight this so you could be able to see it. So just type this code in, resize GL, and GL metrics mode, GL low identity, and GL viewport are OpenGL commands. Once that's done, now we are going to head to our initialize GL, and we're going to add these 2 lines of code. And basically what these 2 lines of code is that when we run the program, we are going to print out our data, meaning we're going to verify that our initial data before anything is done to our ship reflects what's being declared here. Once you type that down, or once you type that in, compile. My mistake. I forgot. It is a function call. So make sure the function syntax is there. My mistake. Recompile. Run it. And double check our data. Okay, we're just double checking and make sure that our data reflects what we initialize. So that's correct, that's correct, that's correct. Now the next step, we want to see what happens to our vertex data as the ship position is being added to it. So we know it, so we have an idea, so we can have an idea what is exactly going on when we're pressing the arrow keys. So go to your paint.gl and add this output line within your for loop. Once that's done, rebuild and run it. And you notice in our console output, the number just keep coming down. And let's resize our window. Now let's press the up key and see what happened. We press the up key, and you notice the number keeps increasing by 1. Now we're gonna press the down key, see what happened. Keep pressing the down key, and the number decreased by 1. That's up. Let's go left, right, and you notice our number just increased infinitely by 1 no matter which direction we hit the key. So we go back into our code, and then we just think about this. Why is it repeating itself? Okay, this is why. Our code works properly. It's doing exactly what we program this program to do. What happens is that my timer, every 100 millisecond, it times out. Once it times out, my update gets called. My update right here, what it does, it creates a new frame, a clock new frame, and it repaints. Repaint tells our Qt widget to repaint itself, or paint. Repaint will call paint.gl. And when paint.gl is called, what happens is that our shift position has not changed because we pressed our key once only. So the shift position stay the same, but what happens is that each and every time repaint gets called, it gets added into our vertices. So it gets compounded. It keeps adding to itself. So times out, my update is called, repaint is called. So repaint calls paint.gl. Paint.gl will update our vertices with the same shift precision each and every single time. So hence, the number keeps increasing or decreasing without stopping. So how do we stop that? So in order to stop that, what we have to do is that we're going to take this code, cut this code. I am going to comment it just for documentation purpose. But you guys cut that code, scroll down to your key press event, and press and copy and paste. Make sure. So we're going to paste it here. The reason why we want to paste it here is because when we do a key press event, according to what key we press, our shift position X or Y gets updated accordingly. And once that's updated accordingly, then we add our shift position to our vertices. And once we add our shift position to our vertices, we print out the results of it. And then once this function ends, Qt will automatically calls paint again, and what paint does is just paint our triangle. So let's see what happened. Compile, run it, resize your window. Well, I'm gonna resize it so you guys can see it better. Okay, now let's see what happened. I'm gonna press up. Okay, it works. You just move once and stay. But we gotta make sure our data is correct. Let's press up one more time and see what happened. Now, double check if our math is being added correctly. You notice we started with 0.1, one of its vertices, the Y vertices. We press up one time, it turns into 1, 2, 3. It actually turns into a negative number, which is not correct because a positive plus a positive is a positive, not a negative. And I press up once again, it is a positive number, but it's not the correct number. And you notice on the X size, the X, when we first started out, the X is correct, but once we press a key, the X then suddenly becomes negative. Now let me press down, and you notice when I press down, data, let me press down some more, the Y coordinates start jumping. Negative 62 and negative 74 is not a difference of 1. So I let me try to press left and right, and when you do this, you could double check your data to see if it's correct. That's why we used cout print statement, so that we could visually see the number or our vertices. And based on the evidence here, there is something definitely wrong. Now we can ask ourselves, okay, why are the numbers not increment or decrement by 1 but by several? So we need to go into our key and just think about it and ask ourselves, maybe, just maybe, each time we press a key, the key event gets called multiple times. So how do we check, or what do we need to do in order to verify if that is true or not? To do that, we're going to create a global variable, and we're doing this strictly for debugging purpose, and we're going to call it num key press, and let's initialize it to 0 to make sure that before a key is pressed, num key press is 0. And within our key press function method, we're gonna increment it num key press. And once we increment it, we are going to do a print statement so that we can be able to see how many keys press. See out. Let's call it number of key press, num key press in line. Okay. So each time a key is pressed, we're gonna increment our num key press by 1. We're gonna print to screen the value of num key press, and we're going to update the shift position, and we're going to change our shift position with our print out our data like so. Now compile, run it. 1 key press. Okay. 2 key press. That's 2. 3, 4, 5. And you notice our key press is incremented by 1 only, but our vertex data is still incorrect. So it is not our key press or the key event that is being called multiple times. It's being called correctly. Each time you press a key, the key event is called. So it's not pressing the arrow key that causing the error. It has to do with the math. So we're going to have to go back to our program. Now what should we do? Okay. What we can do is that for our math part, having this for statement out here, we could maybe access each coordinate system itself with each call, like so. Let's do this, and let's call this Y. So right now what we're doing, instead of having the whole vector 2D being added, we're going to access the individual data itself, the X and the Y coordinate, and add it together. So the shift position X will be added to the vertice X, and the shift position Y will be added to the vertice Y. Now if we were to compile it, run it, let's see what happened. Let's see if that will fix our problem. So 1 up, 2, 3, 4, 5. No, that didn't solve our problem whatsoever. Left, right. Okay, so we go back. This won't solve it. Now what can we do? What we could do is that instead of updating the shift position up here, what if we add this for statement within our if statement and just update our vertices according to what key the user press. So we could try that. So what we're going to do is we're going to cut this, go into our first if statement, paste, let's tab or make it nice. So our shift position, we're going to comment it out for now. And once if a user press up, we want our coordinates to be incremented, so we can, let's take this out. Let's see, our Y gets changed. The Y gets changed, so we're gonna take out the X part, and instead of shift position.y, we're just gonna add the number itself, 1.0f. We can leave this here. So we want to see our data to make sure that it is correct. And we're gonna copy this for statement, go down to the next if statement, paste. Now the key down, we're gonna -1. So we're gonna minus, go to our next if statement, paste. Now this is X. Make sure you comment out the ship precision. So comment that out and X. So we're not gonna go vert Y, but we're gonna go vert X. Vert X. And we're gonna -1. We're gonna copy this. Go to the last if statement. Comment out the ship precision. And we're going to this -X. Oh, this was supposed to be plus X. No wonder. This was plus X. Or +1. So let's look at our code again. In our first if, it's going to be +1 to our Y. Our second if, which is key down, is going to be -1 to our Y. The third key right is going to be -1F to our X. And the last if statement, the key left, is going to be +1 to our X. Now let's compile. Run it. Now let's see. Up. Our data is still incorrect. Up. Let's see. Negative, negative, up. Down. Up. It's still incorrect because our start precision of X is 0. And when you press up one time, it jumps to a negative. Our Y is not being added properly because it's negative becomes a positive. So we need to go back. Let's see what's going on. I recognize what's going on. It's our data. Key up, +1, key down, -1, right. Our X supposed to be +1. Our left supposed to be -1. So compile, run it. Let's go left, -1. 0.1 is -1. Our Y stay the same. Now let's go right. Our data is correct. Now let's go right again. And our triangle is right there. Let's go left, up, up, down, 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 1.9, negative, that's correct, 1. And let's go all the way down. You notice that it is correct. All 13, 14, or 14, 15, it's incremented or decremented by 1 each key press. And then if I press up again, you see our triangle. Perfect. So our algorithm is perfect for now. So let's close this and let's touch this up real quick. Since our debugging process is over, we're going to touch up our program to make it cleaner. So we're going to delete num key press. Or you can comment it out for documentation purpose. So we're going to delete num key press and the cout comment. Let's delete all the ship precision comment that we did earlier. Make sure our curly braces. Okay, one last thing we need to do to make this more professional, instead of hand coding the number, let's give it a variable. Let's call it gl float, and give it a good variable name. You could call it ship precision, You could call it move, you could call it movement. I'm just going to call it move precision and give it a 1.0f. And we're going to change every single instances of our 1.0f to move precision or whatever variable you declare up here, like so. And just like the video 31, let's make this number smaller. Let's compile one last time to double check our work. Run it. See our start of program printout still there. We'll delete that later. Okay, now up, and you notice our triangle is working properly, like so. Now let's close it, and oh yeah, you can either comment out the cout or delete it. Let's delete it because we don't need to see our vertice data no more. So delete that. Go to our initialize GL, delete the first two lines that we did, and there you have it. Now let's do a quick recap. We add our QDebug and our not QDebug, but we added a QGUI QKey event. How should I say this at the beginning of the video? We also need to include the IO stream and using namespace std to use our cout to print the thing to our console. So sorry about that. With a vector2d.h, we include string using namespace std, and we added a new method, toString method, within our vector2d struct. MyGL window.h, we add a new method called resizegl, and in our CPP, let me make sure this is very visible. Okay, we took out the for statement within the paint GL. We defined our new method, resizegl, with geometrics mode, GL load identity, and GL viewport. Then we re-implement the key press event with a variable, a float, with move precision. And then within each if statement, we add a inner for loop to update our vertices coordinate according to the key press that the user press. So up gets plus, down gets minus, right gets plus, left gets minus. And there you have it. I hope that this debugging process has been enjoyable for you. So until the next video, do have a great day.